What we see as light and feel as warmth is the result of a fusion reaction in the core of our Sun. Over billions of years, the gravitational forces at play in the universe have caused the hydrogen clouds of the early universe to gather into massive stellar bodies. In the extreme density and temperature of stars, including our Sun, fusion occurs. Atoms never rest. The hotter they are, the faster they move. In the Sun's core, where temperatures reach 15 million degrees, hydrogen atoms are in a constant state of agitation. As they collide at very high speed, the natural electrostatic repulsions that exist between the positive charges of their nuclei is overcome, and the atoms fuse. The fusion of light hydrogen atoms produce a heavier element, helium. 20th century fusion science identified the most efficient fusion reaction in the laboratory, setting to be the reaction between two hydrogen isotopes, deuterium and tritium. The DT fusion reaction produced the highest energy gained at the lowest temperature. It requires nonetheless 10 times higher temperature than the hydrogen reaction occurring in the Sun. 1 gram of deuterium and tritium can give as much energy as igniting 8 tons of oil, and most importantly, the reserves of thermonuclear fuel are practically inexhaustible. ITER is the one of the most ambitious energy projects in the world today. A new, large-scale, sustainable and carbon-free form of energy is urgently needed. The following advantages make fusion worth pursuing. Abundant energy. Fusing atoms together in a controlled way releases nearly 4 million times more energy than the chemical reactions such as the burning of coal, oil, or gas, and 4 times as much as nuclear fission. Sustainability. Fusion fuels are widely available and nearly inexhaustible. Deuterium can be distillated from all forms of water, while tritium can be produced during the fusion reaction as fusion neutrons interact with lithium. No CO2. Fusion doesn't emit harmful toxins like carbon dioxide or other greenhouse gases into atmosphere. Its major byproduct is helium, an inert non-toxic gas. No long-lived radioactive waste. Nuclear fusion reactions produce no high-activity long-lived nuclear waste. Limited risk of proliferation. Fusion doesn't employ fissile materials like uranium or plutonium. There are no enriched materials in a fusion reactor like ether that could be exploited to make nuclear weapons. No risk of meltdown. A Fukushima-type nuclear accident is not possible in a fusion device. It is difficult enough to reach and maintain the precise condition necessary for fusion. If any disturbance occurs, the plasma cools within seconds and the reaction stops. The quantity of fuel present in a vessel at one time is enough for a few seconds only, and there is no risk of chain reaction.